commands like print working directory. Module 4, I have a few things left from Module 4, but I'll be uploading that here shortly, Jason. So we talked about print working directory, that command. We talked about making directory. So we made a directory. We talked about renaming directories with the mv command. All right, so you can see that got renamed real quick. We talked about different ways to list documents, one being TAC-LF. We talk about removing directories. And there it goes bye-bye. All right, we talked a little bit about VI and some different editors, so let's go ahead and jump onto this. So let's pick up right around the command find clear. So if I just type find, that finds quite a bit. So let's try to narrow that down a little bit. Clear find pass WD. In this case, no such file or directory. So how about if we find shadow? It says no such finding directory. So why not? So this is actually looking in my home directory here. If I want to search for another place outside of my path, I'd have to change the directory. So I could do a change etc and then do a find pass WD, and it'll tell me in that local directory, there it is. Or find shadow, there's my shadow file. Or if I do an ls, I can see a little bit better of the details about that find. So it really only works if you're in a local directory. Now if we're in something like change directory var log, find star log, this will tell me all of the log files in that directory. Convenient if you are in that directory and you want to find something quickly. Okay. However, there's other commands like the locate command. But before we get on into that, let's talk about some of the other things that we can do. So let's do a manual for find and see what that does. Searches for files in a directory or hierarchy. So you can see we can do something like this right here. So we can find a bunch of commands. Don't forget to put your microphones on mute. Find, then the path we wish to find if we don't want to move to that directory, and then any sort of expressions that we want here. Mostly what we're looking for here are some of the properties, and so I have these listed here, right here. Things like access time, create time, modify time, if it's an executable or not, name, size, type, user ID. And I gave plenty of examples here on different types of things that we could find. So I'm going to get out of that, clear my screen. So let's do something like find a time 0. So this finds those parameters. It basically finds everything that begins with a dot, and the access time basically 0. So I have a few things that come back in that search result. If I do it again and change that to a 1, you can see it changes slightly. Or if I do a find, I'm just going to go through a few of the examples here. Size 1K. All right. Or if I do an LSLF, you can see that I've got ADMs, roots, things like that. If I want to find something via a particular user, I can do that as well. All right, and that'll bring up all of the root versus Leo, which I don't think I have anything in here. It's lowercase Leo. So even if you, excuse me, if you're looking specifically for username, it has to be the correct username. So I am lowercase Leo, not uppercase Leo. So in this case, Leo is not the name of a known user. It actually is smart enough to tell you that. So in this case, good error messages are good. All right. So we can go ahead and clear our screen there. So let's do a find. Type. Yeah, well, this is a Linux system, so now that's actually let's do log, find log, actually, find type, test conditions for find. So with the right syntax, it would actually find that specific type of file. Typically like a binary file you would reference here. So also you can do things like inodes. You can search for links, create times, modified times, users, groups, the type of file. So you can go through those and the different variants of those. All right, so next let's move on to the locate command. So we're going to clear the screen, and if you just type in locate, no pattern to search for specified. So in this case, it's got to be a little bit more specific. So let's say I want to find something like all JPEGs. So if I can, actually, let me clear up the screen and give you a chance to see that. So locate star JPG, all right, and that will locate all JPEGs. But notice the format doesn't really help us out too much here. One, there's a lot of them. As I scroll up, you can clearly see that. And I may want to actually have that formatted differently. So let's do, we can use a reformatter, xarguments, xargs, ls tac lf. Right? And you can see that we get that in the format that we want. This is the outputs reformatted in a ls tac lf. So if I clear the screen and hit up there again, you guys can see this. So I'm basically saying locate all JPEGs, and then the output of that becomes the input to the next command, which is display the results as a list, tac lf. Or let's say if I want to locate passwd, right? So this tells me all of the password files on my system, right? And so you can see this is where you start getting into understanding and learning the different directory structures. Excuse me. So like for example here's your classic Etsy password, but I've got cron daily passwords, I've got pluggable authentication modules, change passwords, I've got a handful in user bin, user includes, user sbin, user share, documents, manuals, etc., etc., or variable libraries, packages, and you can see different lists. So this is another convenient command, and that's simply just locate whatever you want to locate. Now there is a secure version of this, so slocate. Okay. Now, in this case, this is not installed by default, but if we come over here to Unix land, okay, we could install this if we want to. slocate, security enhanced version of GNU locate. So if I zoom in, you can get the idea of what this looks like as well. slocate, instead of a database, the string, you can do regular expressions, you can put it to a file. So secure locate provides a secure way to index and quickly search for files on your system. It uses incremental encoding just like GNU locate to compress its database to make searching faster, but it will also store file permissions and ownership so that users will not see files that they do not have access to. Okay, so very similar to locate, create slocate database strings, exclude certain directories if there's something that you don't want to see, for example. A case-intensive search, you can use an I for case-intensive. You can do quiet mode, which any error messages are going to be suppressed. I never used that one. You can do regular expressions. Or even verbose, verbose mode, you can do that as well. So if I get rid of that and kind of compare that, all right, actually, let's compare that to manual. Man for locate. And if we scroll down here, you can see certain things are different. So locate doesn't have a verbose output where slocate does. So you get slightly better search results with slocate if you use the verbose option. Okay. All right, next we can do whereas. So like, again, I love the Linux humor here. Where is cat? Command WHERE, spell it correctly, where is cat? And it'll tell you, hey, we found cat. It's in the bin directory in the user share manual. So here's the actual executable, and here's my manual that goes along with that. And it's actually stored in a compressed format. And you can do that for any of the binary files. So just to give you an idea of what's in the bin directory, let's go ahead and change to it. There's going to be a bunch of stuff in here. This is one of those very helpful directories to know by default. All right, because if you go back into
Hey, Leo, excuse me a minute. I can't hear a thing you're saying. Whoever's not muted, I'm not be able to hear you.
Who's talking?
This is Michael. I can't
Michael.
hear.
So that means Mark, Jason, Tommy. Michael, can you hear me now?
I can hear you.
Okay. I think Tommy was our culprit. I had to put Tommy on mute. Thank you. All right. So let's rewind here. Clear. That's actually no help whatsoever. So if we do it like this, the bin directory is one of those ones that is going to be very, very helpful. Now, let's back up big picture moment here for a second. When I learned Windows, when I wanted to become an MCSE, I took my CD to install the software, and I just went through that file system, that install, and I learned every single command on it from the command line. So it's right now what the equivalent of what you're seeing here is the Windows System 32 directory. This would be the Linux System 32 directory, but it's in /bin. So any of these commands are really fair game to learn. If you wanted a list of commands on a Linux system to really spend your time learning inside and out, you could print these to commands. So let's go ahead and do this. So let's clear the directory. Let's do an ls here, lf, and append the result to home Linux commands.txt. And we're going to do this a different way. So if I cd to home and then vi linux commands.txt, now I have a whole list of really good commands to start going through and start learning these and checking these off one at a time. I mean, some of these are going to be obvious, like ping or print working directory we've had some time with. And the reason why I show you guys in this exact format is because most Unix people think to themselves, oh man, there's so many commands. I don't. How am I going to ever remember the commands? Well, first, where are the commands stored? And then two, how do you learn them? So where are they stored? That's an easy one. That's in /bin. And then how do you learn them? You could just literally start going through these one at a time. So I'm going to exit out of VI, and then I could do, manual for PWD, right? All right, or manual for locate, okay, or manual for ping. Question?
Yes, Leo. This is Mike. I'm going back to the DOS days where sometimes when you're in a certain directory, you can still execute commands that are not part of that directory. Is that the case with Linux, where some commands you have to be in the /bin directory to execute the command, or will all commands be able to be executed anywhere you are within the system?
You can bounce around. You just have to give it the relative path. So, like, for example, when I did an ls, I was in another directory. I think I was in the bin directory, and then I put my output somewhere else, denoted by here. So I just had to tell it where to store it or tell it where to run it from. And it's a very good question, because sometimes you'll run things and it'll say, command not found, and that's because it's looking in a local path or a local directory for something, and it's actually being stored somewhere else. So, you can always take the shortcut, which is just, tell it to run wherever you are. And if it errors out, then you can try adding in the relative path to that. That would be my, my 2 cents on how to actually learn this. But yes, just like in Windows,
okay,
you can run things outside of your path. All right. So I'm actually over here in let's see, where am I? Let's see, was it so where is cat, for example, or which cat? All right, and you can see these give you very, very similar outputs. So where it is gives me the command for it is, so that'll tell you that relative path. Now, since we're doing a 3 certification in one here, this will be different per Linux system that you're on. SUSE has a different directory structure than Red Hat, for example. Yeah, and you can certainly add things to your local path, but now you're manipulating variables. I forget what module that is. I think it's like module 6 will learn how to customize all the the paths and the variables and things like that. But yeah, you can certainly add it. So big picture here, as Jason is noting, is what system are you on and where are things located relative to that, and so that way you can get acclimated to your environment. So the first piece of that is, finding them and making it relative, and then the second piece of that is, well, now that I'm going to be on system X, if you will, then let's go ahead and manipulate our environmental variables so that the Unix system just does what we want and we don't always have to bounce around or learn all the file structures. Keep in mind here that in a Linux course, right, we're going to cover, what's in this directory and what's in this file structure, and it's basic. But once you start bouncing around between different blends of Linux, things will move around for you. So you need to get relative to where you are. And that's why, things like where is cat, it's probably going to be different on a Red Hat versus a SUSE versus a Fedora versus a Kali versus a pick a blend of Unix. So that's where is. Where is it will come in handy versus which finds executables in your path variable, where is this finds the source code and the man page files on your system. For those of you that are testing and prepping for the exam, you should know the difference between these by now and get used to doing, which versus where is versus, whatever command you're doing on the different systems. And that I want you to compare the outputs to see, like, for example, slocate, okay? It's not on this system. It may be on another system, and you may not have to install it. But if it's not on the system, well, then I want to learn, how to install it to add it. So it's all relative at the end of the day. I do have a little section here for grep. All right, so there's a handful of things that you are going to need to learn about grep. You could almost probably teach a course just on grep itself. I mean, like a nice 2-hour, 3-hour module just on grep. I mean, some of these commands we go down into the rabbit hole. So let's do the manual for grep, and I want to point out some of the basics here. So first is there's different versions of them. You have grep, egrep, fgrep, and rgrep. By default, just about every system you're going to be on has grep, but not all of them may have egrep. So if I do egrep, okay, that's installed. Fgrep, that's installed, etc., etc. So you can learn or actually let's do, if I pull up the manual page for egrep, it's realistically the same thing as grep. So it's grep, then whatever options you want for the specific pattern, and then the file. Now, grep is one of those commands where this pattern piece of it in the command structure is going to take some getting used to. Let's kind of well, let's start from the beginning. All right. So description. So grep searches the named input file or files for lines containing a match to that specific pattern. Okay, and it'll print the outputs for you. I never really use version, but I guess you could do a grep, tac v if you want. Here's your regular expressions, your strings, all right? Some of these I use every now and again, not too much. The ones that are really designed for this course I actually put in the document here, so C, I, L, N, R, and V. And these particular expressions here, but I want to when I cover these right here, I actually want to show you in the actual help file. So I'm going to pull that off to the side here. So the first one here is C. C is for count. So expresses the normal output. Instead, print a count of matching lines for each input file. So, all right. So let's go ahead and try that. So if I do a grep C, and let's do X in the file, etc pass WD. So in this case, what I've done is I said grep, give me the count for every time you find an X in the password file. Now, that's extremely popular and extremely helpful because sometimes when you're looking through log files, like for example, failed logon attempts for a particular time frame, you just want to know the number. So it's one thing to say, okay, here's grep from a Unix point of view, but from a pen tester's point of view, you know, we have to put this to use, right? So, you know, what would we be looking for? Why would we want to know the number? And I would probably use this in its exact format in some sort of log file to tell me the total number of matches matching whatever the expression here is. So if I let's do less for etc password. Okay, now you can see here in the file I've got X, 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 right? So I'm basically saying give me the count for every time you see an X. Now specifically within an etc password file, anytime you see an X here and you don't see the password hash, this X is really just a placeholder, which means that it's actually in the shadow file instead. And then that's kind of like one of my frustrating catch-22s. So the reason, you know, the security thing is that we take things out of the WD file and we put it to the shadow file. So that way, you know, the hash is not in the etc password file. Now that was great and all in theory, but the fact of the matter is, anybody that has worked with Linux long enough knows that the companion file to the password file is the shadow file. So we just do the same thing again and just do shadow, right? And you can see the password hash for the particular user. Okay. So there it is. There's the actual placeholder of it. Right? That is my hash on this system. Which ironically enough, it is actually it's different. I thought it was the same as my root password. Just a quick observation. All right. So that was grep for the count. Ignore case-sensitive pieces of this. So if I wanted to do, I'm going to add an I to this, but instead of looking for lowercase x, I'm going to search for an uppercase x. And you'll notice I get the output of that. But if I take off the I, then it was actually going to match the case. It'll tell me 0. So that is another very, very convenient option here. If you make, it all depends if you want to ignore case or not, right? So I could grep for, you know, Leo with a capital L, and it doesn't tell me anything. But if I add in that I to that, okay, then it does. It says, hey, it does match. If I ignore the case here, I do get a match. Extremely helpful when you're looking through log files. Okay. Then you have L, would list the names of the files. Okay, that really isn't too helpful here because it just tells us the name of the file that we found it. You might be interested in N, a little bit easier. I'm going to do an IN because N lists the names and the number of matching lines. In this case, it just tells me 1. And also you can negate these too. Maybe you want everything except. So we can keep that as an uppercase L. Let's go ahead and take off N and do a V. All right, so in this case it tells me everything. How many lines other than Leo do I find? So there's 34 lines total, and if I subtract Leo from that, then I get 33 here, and that logic matches us. Okay. Now you can also, what is in my opinion a little bit more helpful here, is to actually put your results somewhere. So what we're going to do is put our results somewhere. So in this case, if I grep for Leo in the Etsy password file, you can see that output here. So I want to put that somewhere, and there's two ways to do this. We could do a single greater than or a double greater than. Personally, I always do the double greater than unless I know exactly what I'm doing, which calls for just a single greater than. It's really replace versus append. A single caret or single greater than is replace. All right, so before I do this, let's touch a file called grep Leo. Okay, and then let's do a manual for the manual command and append that to grep Leo. And in this case, all I want is something in that file. So I want to see the tail of grep Leo, and you can see the last couple of stuff in there. Obviously, it's the last couple of lines of the manual command. So that's fine. Okay. Now what I'm going to do is I'm going to replace that with grep Leo. So when I do this, replace, whatever was in that file grep Leo before is now going to replace with the output of this command. So I just want to prove that this works here. So now if I do a tail for grep Leo, I can see the contents of grep Leo are now accurate and replace whatever was in there before. But let's say that I would just want to append them. And I'm going to do this a couple times just to show that the appending is actually happening. So let's do a tail, grep Leo, and now you can see that I basically have appended. You know, did it a couple times. It got a couple different results. Like I said, I generally use the greater than more times than not, especially when you're penetration testing or trying to do your reconnaissance on a particular host. So I may do an nmap command, you know, which actually is installed on the Debian system by default. So if I run an nmap command, I may want to just keep appending this. So I'll do an nmap, I'll do an SSL scan, I'll do, I don't know, a variety of scans, NIC2 or something like that, and I'll just keep appending it to the same document, and therefore I can build a log file of everything that I've done during that particular penetration test. And so as I run these things, it keeps appending it. So very, very, very handy. Let's go back to the manual. All right. I want to show you guys down here. This is where things start to get tricky. So if you're uncomfortable with what we're doing so far, this is going to get real uncomfortable. And it basically starts right in here. Basic and extended regular expressions. In the basic regular expressions, the meta characters, question mark, plus, bracket, bar, parenthesis, and things like that lose their special meaning. Instead, use the / version of that. So instead of in my command string, instead of just having a question mark in there, if I'm going to search for something, I have to preface that with a / first. So if not, it's going to read that back slightly different. Okay, so it's not too hard to remember. And anytime you get a question mark, a plus, brackets, bars, or parentheses, just preface that with a / first, and then your search will actually execute. Otherwise, it's going to error out. So keep that in mind. So that's one piece that gets a little crazy. probably all I want to get into here and now. I mean, it's not, this whole document is probably, geez, a page or two at best. So it's not too bad to really print this out and kind of go through this document. I will tell you, I don't have a stack of printed out Unix commands in my cubicle. So, but there are a handful where you do want to get into, and of a command and you think it can do it, but you're just not sure. So you might just want to print out the help file, and something like grep, you actually might get better results online. Otherwise, this is probably like 3 or 4 pages worth of stuff. One last thing while I'm here, it will give you relative commands to that. So, think like the cousin of grep, awk, diff, find, gzip, perl, sort, zgrep, mmap. These are cousin commands, so it's always, if you think a command does something and it's like, that command doesn't do it, you may want to search one of these commands to see if it'll do it, like the diff command. If you want to compare 2 files together, I mean, that's a good command to use. All right. So one of the things that's completely testable here is the format of these things, right? So this is why I have things like the plus, the question marks, the brackets. All of these must be prefaced with a backslash if you want them to work. So what we can do here is actually I want to try this. I actually want to demonstrate this and show this, but forgive me, I got to make this up on the fly here, so bear with me. So let's touch a file, and we'll call this grep lab. And then we'll vi grep lab. All right, and I'm going to put an insert here. And I'm going to put a question mark, a plus sign, a bracket like this, a bracket like that, maybe 2 brackets like this, 2 brackets like 2 brackets like that, and then a colon Q, and that'll get me out. Colon right quick exclamation. Notice down here in the bottom here. This is one of those things, if your eyes are up here and I'm working down here, I lose you real quick. So all I do is create a file, put some stuff in it, and then colon, write it, which is basically save it, quit, and then force it to. There you go. So now let's see that file. So tail grep lab. All right, and you can see the contents of that. So now if I want to grep for question mark in grep lab, okay, I got a question mark, but if I backslash it, it'll actually give it to you. It probably wasn't the greatest example here because that actually gave me some results. So let's try a bracket. Invalid regular expression. All right, so now let's preface that. Regular expression. That actually should have worked. There you go. Versus if I take that off, actually that pulled out too. Huh. Okay, make me look like a fool. I can tell you that there will be times where that won't work. In that case, we actually get our results. Okay. And well, you win some, you lose some. That's what you get for making stuff up on the fly. It really depends on the complexity of the string, the results that you get. Also, there's differences in the commands, like if you do a grep versus egrep, okay, egrep question mark grep lab, obviously that brought out a lot more. All right, so there are differences, in the commands. All right, so fgrep does not match expressions, but egrep does. So if I try to do an fgrep here, you can see how the outputs change slightly. All right, so here let's get a little complex now. So what I'm going to do is do a grep, and I'm going to do a single tick A, and I'm going to look in user share dictionary words, and in this case, no such file or directory. Oops. Well, there you go. It was correct. There is no such file or directory called dictionary words. But if I do it like that, there is. All right. So basically, all I did is basically go give me every single. Well, let me look at the command and translate this for you. So basically, I said, give me everything. Give me A, everything that comes before A dot, and then A. So basically, give me different versions of this, and look in the file words, which is actually a dictionary file in the user share. All right. So there you go. And then N is list the names and number of the matching lines in the file. So, and I could add a pipe more to that if I want one scream at a time. And in this case, you can see, everything from Alabama. It's going to pull up every single word with an A in it, because that's basically what I asked it to do, which there is, quite a lot in something like that. All right. You could also do things like, all right, now this, let's start over again. This is extremely helpful. Grep, show me the color of X in the Etsy password file. This is really, really, really nice, especially when you're looking at a black and white terminal all day long. Now all of a sudden your search string pulls right out there, real nice color. I probably use this a lot. All right, and the same thing here. If I want to append that to grep results, and we're going to call it test.text, and then I less grep results text. All right. Now, since I stored it to a file, notice it's not read. Okay, so you lose that if you try to store it somewhere. Now I'm going to replace X with Leo here. I didn't want to do that. Whoops. All right, now I'm being stupid. There you go. So in this case, it just matches, that specific example. So I basically say make Leo a color, And it will change depending on how, some people like green text and black background, whatever the case is. I forget the rules of why it actually formats in red. I know you could change it. I forget off the top of my head how to actually do it, but depending on how your terminal is set up, that will show you. Also notice when I highlight the terminal too, that's another easy way if you don't get a nice contrast between the two. So let's do a look, quick Q&A. Marcus had a little comment here. It's a double backslash in the grep, but I think it also is specific to what command you're doing. So I also went through fgrep, grep and egrep real quick and just did the results. So with fgrep, it gave me my plus. I did a double backslash, it did not. I did a grep with a double and it gave it to me. But if I do a grep with a single, I think that gave it to me as well. Yeah, so it depends. It's not as clean as you'd like it to be, just for the record. Any questions? For my terminal, it's just control, not control shift. But yeah, there you go. Yep. All right, next, let's go on to copy. All right, so let's look at the manual for CP. All right. Copy files and directories. So it's copy, then the option, and then the source, and then the destination. All right. So some of the things in here that are I have listed out here, the most popular ones that you're going to have to know, and a quick little example or what it is. So I think this is the format that I'm going to stick to use. So TAC F for force, TAC I for interactive, and so I underlined the word that should be the keyword associator with how to actually remember that. All right, so let's go down here. Here's your F force. If an existing destination file cannot be opened, remove it and try again. Redundant if the TAC N option is used, which we really don't cover that in this course here. Then you have I, which is interactive, prompt before overwrite. That's helpful. That prevents you from overwriting stuff accidentally. Then you have T, come down here. T for the target directory, copy all the source arguments into a directory. So T is really for target or destination. You have U, which is update, copy only when the source file is newer than the destination file. If you keep your directories relatively the same, you're not rearranging them all the time, and you constantly just want to, get all of the updates to the destination directory, you can use this sometimes. Then R, which is your recursive, and you can do this in a lowercase r or a capital R, which basically all the subfiles and folders will go along with that. So that's very, very popular. All right. All right, so let's do some examples of this, okay? So I'm going to touch source, touch destination, and then I'm going to copy my source the file called source to, well, let's check this, find the destination. So if I do have a directory here, Leo. So let's go ahead and, I lost my command. I did not go over. Source. Source is here, so I didn't do it. Let's try again. Let's see where I went wrong. So CP tech R, well, I don't need the R because there's really nothing recursive there, no subdirectory, so actually we can get rid of that. So copy the source to actually that was dumb. Cannot stat source. Or maybe it did, because it's not there. Oh, because I'm in it. The problem is I'm already in that subdirectory. So let's do, here you go. So source is still here. So let's put something in file. Let's do something else first. Let's do, I got to get back here. There we go. So let's, manual, pipe that to source. Okay, so now we got some stuff in source. And now I'm going to copy source to source 2. So that's just regular copying first. And then if I tail source 2, right, and then you can see last 10 lines of that file. So basically that's a real easy copy one to the other. All right, so that's real nice in you know, from a Windows comparison. You know, right click, copy, right click, paste. That's a whole lot of waiting when you can just, you know, copy one to the other, you know, real easily. All right, so there you go. All right, we've already done the make directory command. As I'm going through my cheat sheet here, we've already gone to the make directory command. So don't forget that when you have spaces, you either have to add a single tick at the end or add a backslash with the space accordingly. So that you actually get the space in the file name. If you choose to have spaces in file names, some people just don't like to do that at all. Also, move, you can, let's look at those. So the manual for the MV command, all right, moves or renames files. So it's, you know, move source to the destination or to a directory. All right, and notice that if you want to do this here, so move tac T to a directory and then your source file. So this is kind of backwards. Okay, move all source into the directory. So let's go ahead and give it a try. So I'm going to go back to the copy, move tac T Leo source. And we're going to do the same thing with source 2. So now if I change directory to Leo, you can see source, and source 2 have been moved over there. So it's adding that tac T here. So you actually have to, it's basically the logic here would be move into the target directory these source files. So it's kind of a little backwards intuitively, because you would normally think copy the source into the destination, but really what you have to do is define the destination and then tell it what source files you want to put in the destination. And that's where most people get that wrong. Same thing with copy. So let's go back to the manual. All right. So F for force, do not prompt before overwriting. You got to know that one. I is interactive, that does prompt. So these are two cousin options that go hand in hand with each other. One do not prompt, and the other one is do prompt. Okay, and then of course T is for your target directory. All right. So just remember that the T comes before. Typically. Now you could say, let's touch source 3 and then touch source 4. Oops, 4. All right, so you can see source 3 and source 4 in here. So let's say you want to move source 3 to tac T Leo. Okay, so I changed the command structure here, right? Before I did the target, and then I told it the source files. Here I'm telling it the source files, and then I'm telling it the target. So with a little bit of luck, you will be able to see source 3 in that directory here. So you can manipulate it, but that's not entirely intuitive if you're just looking at the manual for move, because the way they have it written here is, your target directory and then the actual source. You can specify, the source here and then the target. So let me give you one other example of this that I probably use more times than not. So let's say touch source 5, touch source 6. So we want to move into Leo source star. All right, so what do you think is going to happen here? It's time for you guys to think. What do you think is going to happen here? Actually, nothing's going to happen. Nothing's going to happen because it's the wrong command.
Exactly.
Try move. What's going to happen here?
Should move all source files into Leo.
All right. Sure enough. All right. There you go. Real helpful if you want to go grab all log files and move them somewhere else, like archive them. All right. So good. All right. Next, remove directory. I think we covered those. As I'm going through my notes here. So remove directories here. Touch creates a file. Creates one if one does not exist. So let's play with that a little bit. So touch source 3, touch source 3, touch source 3. Spell it right. Okay. I only have 1 3 here. Okay, so it's not like I get a 3, a parenthesis, a 1, a 2, and a 3. Okay, so this only works if one does not already exist. So, and we can prove that. We can just prove that with it. So if one does not exist, if it exists, it's not going to create it. And we might actually be able to get errors on that question.
Leo, you can make multiple files on the same command line, though, right? You don't have to do touch source 1, touch source 2, touch source 3.
Yeah, touch Tommy 1, Tommy 2, Tommy 3, Tommy 4, Tommy 1, 2, 3, 4.
Yeah, and can you kick me the name Tommy Elliott out? That's not actually me.
I mean, I can. That's probably Marcus.
No, Marcus, I'm logged in as Marcus right now. Marcus is sitting next to me.
It's okay. We're going to just leave him there.
Okay.
But
it wouldn't let me log in, though. That's why I was having trouble logging in.
I mean, if you really want to get on your own computer. Let's see. All right. Bye-bye, Tommy.
Thanks.
All right. All right. So touch, yes, touch. And good observation, right? You know, you can see the difference between the questions between the first running of this class and the second running of this class. The questions are a lot more specific and tailored, which is why this is a good class to actually sit through twice. And these modules, as I give you guys videos for them, one, to rewatch the video and see how it's used and see the different examples of that. You know, every time if I do this class, I mean, I'm sure I'm doing different examples of the commands as I'm working in the moment. All right, so next let's do the T command. All right, so we can do T help, okay? See what the quick version of this is. So T options and then a file, which is the standard Linux way of doing things. So copy the standard input to each file and then also the standard output. You can append, ignore, help, and version. And that's probably it here. So in my notes here, I've got TA path and then file name. And in this case, that's not going to be good enough. I'm kind of doing a little bit of a spell check here in the command. So if I don't type it exactly as I have it in the folder, I'm trying to tweak it so that if you guys are copying and pasting, you guys get good results. Help me. Let's see. I probably should have. So actually, that should have. Let's do make directory path, and then touch path file name. I gotta stop doing that. So now, there you go. Help me. All right, so change directory to path, ls, tail for file name. There you go. So what I did is I created a file, I T'd some stuff, and then typed a bunch of stuff, and then hit enter, or I think I actually hit Control C. Well, we can do it again. So let's do it again. So TA path file name. So this exists now as a folder called path and a file name called file name. And I'm going to hit enter here. And that did not work the way I wanted it to. Oh, because I got to change directories again. So let's try it again. There you go. So Tommy is cool. Marcus is somewhat cool. Will, what am I going to type? Where's Will? Where is Will? All right, and then Control C gets me out of that. Change directory to path. All right, and then tail my file name, and then you can see everything that I put into that actually is in that file name. So it's a real good way to append things. I use that every now and then. So if you want to take some, this is good for taking notes. Make sense? So let's do an example of that while I'm here. And forgive me if this is a little dragged out or slow, but I try to be thorough, and it does build upon things. So if you're bored at this point, bear with me because we're going to get into cooler stuff here a little bit. So let's do make directory notes, and then touch notes Linux, and then T all right, and the reason why I want to show you this is because of the date of the way that I'm going to do this. So today is April 3rd, so we can do April, well, here, let's just do 04.03.2014. We created the second half of files and directories. Okay, and it prints the name of that. 04062014. We did some other stuff. Okay, and then Control C, tail notes Linux. There it is. So when you're in this mode here, when you see the double, that's actually appending to the file. So notice here I see 4 of these, but if I actually go look at the file, I only see my my notes in between hitting enter. Okay, so that would be a good way to kind of build some notes using the T command. All right, next, well, let's do a help. For those of you that have been on the command line for any period of time, you will know that you can just ask it for help. Okay, so let's clear the screen. Let's do a help, and let's do a pipe more. Okay, so help name to find out more about the function name. And here's all the things that you can get help on. Right? This is another go-to place that you will need to know to pass these exams. Right? It's 2 that I've given you today. Actually, you know what? I gotta give me a second here. Let me make a note here in my document here. Search. The first one was search for the bin directory. The second is the help command. Okay, so what I did is I add 2 notes here. All right, and I'll elaborate these later and explain them. So you know, I wanted to have a section in these documents, you know, other notes to think about for later. So as I do multiple versions of this course, you know, if you want the latest and greatest, here's where they're going to be. Okay, so. Two things that so I think of this stuff when I'm actually teaching classes that I don't typically think of if I'm just sitting here by myself. So like for example, pop D command, hey, we've seen that. Push D, pop D, print F, caller command CD, return, declare, disown, false, FC, FG for foreground communications, BG is up here for background communications, the alias command. Most of these things in right here, if you type in help, this is standard Linux 101. And what I mean by that is all of these are pretty much testable. At least at this point, I would express note to self. Okay, so how to do things like loops, like for this, for that, shell scripting. Okay.
Should we know for Debian because that's the exam that's usually tested on?
Yes. The Linux powered by LPI is Debian, but that's not good enough for us anymore. I mean, it is for this particular exam for the Linux Plus, but I want you to try these things. Again, the big picture of this course and how it differs from the last one is this one. I'm having you guys in lesson 1, the install lesson. I'm having you build a virtual machine set of multiple operating systems, and I want you to run through these documents and practice each one of the commands. I want you to go through like files and directories. I want you to go through that in each one of the operating systems that you've installed, so that way you have basically your own test bed. All right, so in the traditional Linux LPI class, yes, you can get away with just Debian. Now that this is a 3-in-1, I don't want you to be SUSE certified if you've never installed the thing or have never logged into one. That's not going to help anybody. So now that we're doing that, I want you to be able to practice this stuff on SUSE or Fedora or Ubuntu and get an idea of how things change, because your learning curve will adjust. At first, you're like, wait a second, you're scratching your head. You're just trying to learn it in one shell, and then now this time, when you do it through multiple shells, you'd eventually, most of the stuff, you'll start picking up your error messages, and you'll be able to adjust and overcome them. And soon it will make a difference what Linux system that you were on. So, like, personally, I get a kick out of people that were like, we want this version of Unix. And I'm like, realistically, should it matter? I mean, if you're proficient with Linux or Unix, it really shouldn't matter which blend, unless you're asking a very, very specific version or question of something. It really shouldn't matter. You should be able to do this stuff interchangeably per system. And when you can go to Debian versus KDE versus XFCE desktop environments and just navigate accordingly, it gets to a point where you can do this and it really doesn't matter what Unix system you're on. And for that matter, it doesn't matter if you're on an intrusion detection system, a firewall, a custom build system, a honeypot, a pen testing machine like Kali. Does not matter. You pretty much see it interchangeably. And once you get to that point, that's a very, very nice, comfortable place to be. Clearly, you're still going to make mistakes, because clearly I still do. Hey man, you guys want to see some mistakes? Just watch me for an hour. All right. So you want some help on something? Help, exit. All right. This exits the shell. Give me a help on BG. This gives you a little help on that. Give me a help on FG, foreground. All right, and you can compare these. Let me clear the screen. Do a help again. Every single one of these you can get a help on. So let's say you don't know what disown is. Okay. Help disown removes each job spec argument from the table of active jobs. Without job spec, the shell uses its notion of the current job. All right. So A for remove all jobs, H for mark, R for remove. Okay, so you can learn. You can learn as you go. So help is a really, really good one. All right, next let's do a file. All right, if you just type in file, you can see Well, first, the big picture here is determine the file type. So let's do file bin cat. All right. All I did was a file bin cat. Somebody translate this for me. What did I tell it to do, and why did I get the results that I got? Who can translate this for me? Okay, let's think about that. Your mics are on, folks. Where's mine? No, nobody?
Just looks like you had an elephant.
What about the elephant?
No, an elf, and then it's like your Intel is your.
Oh.
I have no idea what this is saying. This looks like the operating system, 32-bit, the Intel. But I don't know. And then you're in new Linux.
All right, so it tells you everything about the command cat. Okay, so it tells you where it's located. Okay, it's a 32-bit command. Let me check something real quick. Player preference. That's not what I wanted. I'm pretty sure I have the 32-bit version of this, and I'm going to cheat and go here, and it just says Debian Live. It doesn't say if it's 32 in the actual file name. Just quickly checking the file name. It's an executable. It's for the x86 platform. It's the version 1 of the file. It's a dynamically linked libraries. Okay, it's got a build ID, and it gives me the secure hash algorithm hash, of the file. So if I just change this to TAC, for example, no such. Well, cannot open bin TAC. No such file directory. No, that should have been there. User bin. Okay, so that's actually somewhere else. So there you go. That would be why. So let's learn from the mistakes, okay? So originally I did a cat over here, and I decided to do the reverse of that, and I did a file /bin/tac, and it said error, cannot open bin tac, no such file directory. So I start scratching my head and go, wait a second. Of course, absolutely. We did this last week. TAC's got to be installed, so where is it? So then I went, where is TAC? And it tells me user bin TAC, et cetera, et cetera. And so then I just changed my command. I just had a /user/bin from that, and it gives me relatively the same output as before. So if you want to find information, like, let's do a file grep Leo. Right? In this case, it tells me grep Leo. That's simply the only thing it knows about it is that there's ASCII text in it. If I grab something that doesn't have anything in, like source 3, it just tells me it's empty. So it'll give you information about the file type in itself. I guess the equivalent in Windows would be when we go to a file and select properties and look at it. Or try to recover it, open it, and with Notepad or something, and see what it looks like. So the only other thing I probably want to show you here is if I do a file star.star, okay, this will tell me everything in that directory. All right. So in this case, grep results, only for things that have information in them. So let's change directories to Etsy, and then do a file star.star. Okay, and then we'll do a Control-C because clearly that dumped a lot of stuff. Add user, text, directory, UTF Unicode text. Michael, I believe you're the forensics guy in the class. All right, so I bet you, since Michael's the forensics guy, I bet you he would quickly want to know the different file types of what he's looking at. Am I putting words in your mouth? Marcus, I'll come back to that question in just 1 second. Is that fair to say, Michael? Knowing the different file types, is it C code, is it PHP, is it a directory, is it a script, is it a shell script, is it an executable, etc., etc., etc. All right, so just for, if you do a star, that'll basically do that to the directory. And you could do it to the relative directory if I wanted to do, everything in home. All right, you can specify a relative directory, or let's do a file in var log. Whoops, let's do it in var. I forgot what I was doing. There you go. So lots of stuff in there. Directories, POSIX shell script, rc.local, sudoers, C source code. Okay. All right, so that one's a good one. All right, next we can do, well, actually you guys have seen me do this, and I don't think I've covered this too much here, but ls, right? You can do an LSA for all, clear, ls tac l gives me a list, clear, ls tac I, don't forget that adds the inode piece preferencing your output, okay, ls f, okay, F for classify your file types, so for directories, and then tac R. So you could just do ALIFR if you really want everything, and watch all that. Look at all that excitingness. That'll just keep going. You really want to fool somebody, you work at a help desk, and you have to go to an end user's PC, and you want to kill some time, just go ahead and do an ls. ALIFR at the root of the hard drive, and it'll basically do that for every single file and folder on the darn system. Just let that thing sit there and run. Be doing that for hours. All right, so Marcus had a question. Let's go back to Marcus. Claire. So, which tac? Okay, in this case, if you do a which tac, this will tell you where it is. So it's what we were doing before was file user bin tac. All right, tac is the exact opposite of cat. So Actually, let me clear my screen. So if I cat grep results.txt, you can see all the stuff in there. Notice at the very, very end of the file, all right, this is the bottom of the file, clear. But if I tack the exact same file as opposed to cat it, okay, now the bottom goes to the top. So it displays your results in reverse format. Make sense, Marcus? In other words, you don't have to use some sort of command line switch, which is reverse your output. All right. All right. Next, we can do stat, command stat. So let's do a man for a stat. Display a file or file system status. So it's stat, the options, then the file. Okay. Now, there's a lot of things that you can do in here, and what gets real confusing is all of these percentages, because, I mean, clearly, look at how many there are. I don't know about you guys. I'm not going to remember all of these. I don't expect you to remember all of these. I think you'll get a few of them, you know, right off the bat, just intuitively. But you're gonna have to play with this one. Okay. So stat. L for a file system, display the file system status instead of file status. Okay. C for format. You can do that. And then you can do a %F for file type. Now, keep in mind that I've got this written down exactly how to do that. So you can see the tac C %F. This is the equivalent of doing a tac C. Okay, so give me the format, and then %F, give me the file type. But I could easily change that %F to %G to etc. Give me the inode number. And so that's what we're going to do is do a few of these, okay, and see what the results look like. So let's do stat. Well, let's find some files first. Stat grep results. There you go. So we're basically looking in this section right here. So give me the statistics for grep results text.txt. The file, the size of it, the number of, Michael, you're the forensics guy, don't forget here. You got the number of blocks, the input and output block on the hard drive, the inode number, the number of links to it. That might be relative in the forensics world. The access, the permission, the user ID, the group ID, and then the access, the modify, the change times. All right, so let's do it again, and let's display the results slightly different. So I want C %F. Okay, in this case, it just gives me, remember, C is for type, and what was C for? Format. C was format, and then F was the file type. Okay, so let's say we want to combine a few of these. F, G. I mean, there's pretty much one for every single piece of this. A, B, C, D, E, F, G, H. There's no capital H. I, no J, M, N. All right. So if we get out of that and get crazy here. We could do %A, %A, %B, %B. Okay. And you can start combining these if you want. So if I do stat, give me A and A. Or actually, you know what, let's keep this. Right, so just give me the A's. Now I'll replace the A's with the B's. All right, and you can compare those if you want. Still, not too much different. I actually don't say anything different. Actually, cannot stat be in such file directory. Oh, well, that's because I did a file. Let's try C. All right, same thing. Valid format sequence for files without the FF file system. Actually, maybe we should have kept that C on there. So let's fix it. Failed to get the security context of grep results, no data available. Yeah, that pretty much sucked. Nah. So we're digging in the dark at this point. So you might want to just do something like, say, since the key to file storage in Unix, is it %I? %inode number. All right, so it was lowercase I. So that should have given us the inode number. Oh, that looks really stupid. There you go. All right, so we basically fixed it. Tell it the right thing, gives the right results. Anything else, you're basically digging in the dark. All right. All right, so that's pretty much. Actually, we've got a few more things here. All right, so I left you guys a few things, right? So Google the VI cheat sheet. Okay, I want you to get a few of these different cheat sheets. You can get a Vim or a VI cheat sheet. Go ahead and print that out and use the cheat sheet when you're practicing all of these labs because it'll make testing a whole lot easier. So remember, Vim is the improved version of VI, and I put a link to the actual cheat sheet in itself, which is just basically a Google search result. So there's no sense for me to basically reproduce these types of documents on my own for this course. There are plenty of other guys that have already done great jobs with this stuff. I just assume give the credit to them and do it. So here is the search result, which is the VIM cheat sheets. You literally can go and pick, they got programming ones, they got not so programming ones, I guess somebody's cliff notes of this stuff, or either that or it's advanced calculus. I'm not entirely sure. So those are there for you guys. All right. So next is create a hard and symbolic links, and basically we got to look at the inode piece. So an inode is the absolute key to file storage in the Linux world, and an inode contains data, a name, and the actual inode number. Okay, so when you delete files, it deletes the actual inode, but not the actual data. So the data of the file stays. It's just the reference to the file gets deleted. Okay. Then you have hard links and soft links. Hard links are alternative names for files or data, like if you wanted to rename something. So I have examples of this. You are going to need to know these for your exam, so pay attention to the specific versions of these. Where soft links, these are a reference to a file directory. Sometimes these are called symbolic links. So let's go ahead and do some examples of these. Let's clear our screen. So you see here I type in the PIGN command. Now that is a typo for ping, okay? So if I get tired of typing that incorrectly. And this is where Jason has chimed in before, and he talks about, earlier he was talking about customizing his environment. Well, I'm basically going to show you guys how you guys can do it. So first thing, let's do a manual for LN. Makes links between files, and it's same thing, the command, the option, some examples, like target directories. So the same thing here, target directory if it is a directory. There you go. All right, so some of the ones that I have listed here is the S, symbolic link. Make a symbolic link instead of a hard link. Otherwise, it's the same command. So the difference between a hard link and a symbolic or soft link specifically is the TAC S. And so there you go. So let's get out of that and let's do some. So if I want to ping PIGN, okay, in that case, well, okay, so let's learn from this. I wanted to create a link from ping to a typo of ping, and it says no such file or directory. So we got to find out where it is. And by default, it would have looked in our home directory, which is relative to where we are, and that doesn't help us anyway. So let's go where is ping. And it says, hey, that's over in the bin ping directory. We could also have done find ping, right, or locate ping, right, a whole bunch there. Okay, so we need to specify the right syntax here, and this is where you can learn from there you go. So now if I type in PIGN, command not found. It's actually I probably needed to add that to the bin directory as well. PIGN. There you go. So now effectively every time I type PIGN, I get the ping command. So for those of you who know what typos that you type wrong every single time, instead of dealing in backing up, retyping, backing up, retyping, just create a link to it. Call it something different. Okay? And you know, in PIGN, www.leodregier.com, there you go. It's the ping command spelled differently. You know, you get some results. It actually works. So instead of fight it, make the command shell work for you. All I did was create a link, and I had to give it both the full path. So the regular command and then the new reload name command. So where is PIGN? Okay. Now I'm going to locate that, and it says, hey, by the way, that's actually in the bin directory. And we could have done that so many different ways. We could have changed over to bin and then just do an ls for PIGN and get some good details on it. There you go. And then that's it. All right. Or let's say we want to remove it. Actually, I'm going to go back to home and then remove bin PIGN. Whoops. There you go. All right. And so you can try different locating commands and see what you get. All right. So big picture here, copying versus linking. I could have copied the, if I go back to my terminal, clear, copy bin ping to home, okay, and then you can see my ping command is here. Here it is. Okay. Or I can leave it in bin ping and then just link to it. Right? So I could have bin ping it's already there. So in that case, it's called ping 2. Okay. So in this case, ping 2, www.cnn.com. I did something wrong. No, it's there. Ping 2. Well, I think the conflict's going to come in because I already have ping there. So just cleaning up here a little bit. All right, so now I got it a little bit cleaner. Now I can see what the heck's going on here. So let's go ahead and link to bin ping, and let's put that to here, and let's call that ping. Now you can see ping is right here. So if I just type in ping, and actually that was probably a bad idea because you can't determine between this version and the one in the bin directory is actually being an executable. So let's go ahead and do that again, and then let's rename it. So now if I type in ping 2, command not did it again. Ping command not found. Oh, that'd be why. Forgot to create the symbolic link. Failed to create symbolic link. All right, so rm ping 2. Let's do it again. There you go. Now if I type in ping 2, that still failed miserably. Ping 2. Should have got it. Ping 2 command not found. This should have created a symbolic link, so every time I type in ping 2, that links me to the / bin directory for the ping command and actually executes it. That's what should be happening. So somewhere in here, I've got a goof. As I'm also cleaning up the chat dialog box. Yeah, if you're in the bin directory, you can just do it. This is where oops. No, I was going to look in the environmental variables, but I better do that later. Let's do other notes here that I have on this. You cannot create hard links to a directory. This is similar to creating a Windows shortcut, or Mac in the Mac world they would call these aliases. Find system files and replace these with the correct location. And understand the structure of FHS that goes into that picture below with a large hierarchy. Otherwise, most of these we've got here. Find, located, where is, which. For those of you that are interested in scripting, you have testing and find commands. We talked a little bit about Vim. We talked about Elvis, binary, a virtual editor. Let's look at it for programmers. If you do have removable storage and you want to, let's say you got a little flash card or something like that that you want to install on, you could make a particular file system and format it. All right, so I want you guys to practice actually formatting some sort of removable storage with makefs command. And then the mount command. So you're going to need to know these because in the Linux world you have to auto-mount, or well, you're not auto-mount, you actually have to mount things manually, or nowadays it relatively gets added into user media or any one of the default mount locations. So it's the mount, the type, the device file, the mount point, and any other additional options that you want. So, for example, in the T for types, any of these are fair game. So hard drives are normally formatted as like ext2 or 3. A CD-ROM is ISO 9660. If it's a network share, NFS or NFS4, or server message block file system, or hierarchical file system, MS-DOS and VFAT. Not that really anybody's using MS-DOS and VFAT anymore. Technically, I guess you could. The mount points, common mount points, are in mount media in CD-ROM. So let's take a look at those real quick. CD, let's see, find MNT, or where is MNT? Actually, that's probably a bad idea. So you can see MNT, media. These are the two that we're going to talk about right here. So it's CD to MNT, and there's nothing there. CD to media. Okay, here's where our CD-ROMs and our floppies are. So you could, want to see what's in the CD-ROM. Media. Or CD-ROM 0. In this case, how would that play into the virtual world? I actually think I installed this version of the operating system. My question to myself is, if you're using a bootable CD-ROM, for example, let's go back to VMware, right? So you can see that I've actually set it to use an ISO image. However, I've already installed this operating system, so I actually don't need these settings anymore. So I can do connected to power on, and use the physical drive or the physical CD-ROM and auto detect it to see what's in there. Sometimes you can do this with virtual machine and the settings will take. Sometimes you do this with virtual machine and the settings won't take. All right. That was done. All right. So in this case, do I have anything? I don't have anything in the CD-ROM. So it's blank. No, so I can't show you. So for those of you that have a CD-ROM and have something in it, you can try this and basically look at the files on your CD-ROM. Also, when you're mounting or linking files to somewhere, you have to specify the permissions. So do you want that mount to be read-only, read-write, a specific user or users, executable or non-executable, or auto? So I have 4 decent options here, which is probably going to cover just about everything that you'll do, at least in the introductory sense. So I'm basically saying mount, the type, VFAT, DOS. The device would be a floppy drive or mount floppy, and make it the options of read write for for users, no executable. Question. Questions? Okay. We've also covered switch user and sudo, super user do versus actually switch user. I've been logged in all day as root, which is actually the same thing for that. So let's play around with the sudo command just a little bit. So we're going to change directories to home again. And I want to cat the etc sudo .conf file. And okay. So let's do sudoers. And actually, I may make a note of that. Okay. So if I do this, this is who can use who can basically do a sudo. So you notice here I'm already logged in. So if I do switch user to Leo, okay, and then do mod probe. See, that won't let me find it. Well, all right, so cd2s bin mod probe. Okay, good. So in this case, command not found for regular Leo, but if I do a switch user to root, okay, now I do a, where is mod probe? And then mod probe. Well, at least it doesn't matter. It didn't run. I don't have enough there to actually see it run. But notice the difference between this mod probe and that mod probe. User logged in as Leo. It says bash mod probe command not found. So I did my switch user to a root, and you can actually see that. So now let's switch user again to Leo. Let's say sudo mod probe. And the cool part is that it actually prompted me for my password to tell me that I couldn't do this. Leo is not in the sudoers file. This incident will be reported. Woohoo! Okay, so I can't do this. I can't run sudo. Leo, the regular user, Leo does not have permissions. So I'm going to switch users back to root. Okay, and then actually, let me explain what I just did real quick. Clear. It's vi sudo, okay? That's an important one because that's the specific file for editing the sudoers command. If I do a vi for where is it? CD. VI sudoers. It actually lets me see this, but if I insert testing 1 2 3 control sudo's fire, it's modified, but it's not saved here. So scan : q. It won't let me Okay, see it says down here, sudo is modified, not saved. So colon or right quit exclamation root exists. So it's going to come back with all sorts of head actually that's not supposed to happen. So I wasn't supposed to be able to edit this. Testing 1, 2, 3, 4. You can see that added in the beginning of the file. I wasn't supposed to do that. What you're supposed to use is vi sudo. That's supposed to be like the only command for the root account to actually add someone to the sudoers file. But in this case, I was able to edit it. And I think the difference is the configuration file versus the sudo. So cat sudo.conf. That's what happens when you edit a binary file. But there is no configuration. No. Question to self. So if I just type in vi sudo, it's not supposed to see that. That might have been just for non-root accounts. I don't know if that makes sense either, because then I wouldn't get permissions. I have to think as why it actually let me change that without using vi sudo. This, for homework, I want you guys to review this file, the sudoers file. Okay, this is worth reading one time. So this, and I'll just give you the quick version of this. This file must be edited with the vi sudo command as root. That's essentially what I tried to do. Please consider adding local content under etc sudoers.d instead of directly modifying this file. That could have been a small difference as well. Okay, see the man page for details. Okay, host alias, user alias, command alias, and then here's the piece of that. So here's who can, there we go, and the spam coming in. So root, all, okay, so sudo, allow members of the group to sudo. So this is where I would actually create a group called Linux admin or something like that, and then add the users into the group of Linux admin, and then just define this for a whole group. Or let's say I had a group, intrusion detection engineer or something like that. I'd make the associate group and go along with it. All right. Okay. All right. So all I did was exit out of that and clear it. All right. So I want you guys to go through the sudoers file or the sudo.configuration file, depending on what operating system you're going to be on, and give that a once over. At this point, it's really just a matter of doing test questions. Before I do that, I want to point out here some things that we really haven't spent too much time with. So one of the things that we did in the last class of the Warriors is we looked at mind maps. So I actually have a handful of them. Actually for each one of the domains here. And I want you guys to start using these as well, because that's really step 2. I was a little hesitant to go through these right away, but now that you guys are ready for it, now I can cut you guys loose. So what you have, you basically have two files. You have this file right here, which is going to be our how-to guide to go through, and then the companion for Module 3 files and directories would be the mind map software. Now I have these both in mind map and in PDF format. I'm going to give you guys the PDF format. The Warriors already have these and they use those. So real quick, Warriors, if you're still on the call, we got a couple. How'd you guys like these mind maps? There we go. Maybe not on the call. So the module by module is effectively, like 15 to 20 pages per. And then what the mind maps do is they get these down to 1 pages per module. Okay. So it's just a hierarchical representation of the lesson. Okay. So working the command prompt, print working directory, echo, the different command structure, bin, dev, etc, different things that are in there, mount, CD-ROM, floppy, media, what's in there. Mounts for more like physical things like CD-ROM and floppies, where media is typically where we'll place our mounts, user, var, okay? So I'm going to make sure that these are all I'm going to give you guys all of these for every module up front unless I make changes to them. They're pretty much where they need to be. So you guys can have these and print out if you want the quick version of the course, go through the mind map and practice all of these commands, like pushing and popping directories, copy, moving and removing files and directories, copy multiple files and directories, remove files, right? So each of these are testable objectives according to the official outline of the course. So now that you know that, you can basically go through the copy, the find, the file, ls, move, remove, stat, etc., touching, teeing. And, I even got a little section on VI in here if you want to go, all of the VI shortcuts and things like that. All right, so use these if you like. Okay, they're there for you to use. Now I want you to go. Now, I don't like putting those out there right away. Yes, they will be in the Dropbox. I don't like putting them out there right away because sometimes people take the easy way out. They're like, well, I'll just learn the whole course using mind maps, and you kind of need the module by module command line to go along with it. The module by module is basically a companion to the mind maps. But together, basically, 16 mind maps equals, pass exam if you really use them in a hands-on format. So that brings us to the end of the night. All right. So this is a perfect opportunity to stop. Let's finish up with any questions. Mark, Michael, Marcus, any questions?
Any questions?